Welcome to this demonstration of how we can use Altair RapidMiner to analyze season ticket holder renewals. First off, I'm going to show our Panopticon tool for creating business intelligence dashboards, creating different segments such as who did and didn't renew in 2024, but also integrate with machine learning models such as models to be able to predict if we do a price increase, how is that going to affect the number of renewals and the revenue we bring in. Next, I'm going to show how we create those models. I've moved to the Workflow Designer in Altair AI Cloud. First, I'm going to bring in some data of my previous renewals. Here stored in Excel documents, I'm going to select that from my data catalog. And then I'm going to use a read Excel operator, connect the file to the file input, and run this operator by clicking the Run button below. When this is completed, we see that the data view underneath has updated, so I can now see the data that results. And I can also expand this and do things such as create overview charts. Some examples there shown on screen. Or I can create summary statistics. And the statistics will reflect the different data types. For example, if we move to the next screen over, we can see the renewal date at the bottom, shows the earliest, last date, and the duration. Now I'll build our data pipeline, and I'm now going to use a generate columns to try and generate a new column, which in this case will be called renewal status. Here I'm going to assume that if there's a missing value in our renewal date, it means that the season ticket holder didn't renew. So for this, we're going to use an if statement to begin with. We then want to add in an extra function, which we're going to use the missing function. We can see here this is used to return a true value if indeed that value is missing. So I'm going to say that if renewal data is missing, I then say what happens if it is missing. So I want it to say didn't renew. And of course, if the opposite is true, then we want to say renewed. If I close this, click save, and then update my result, I can see the result of this function and confirm that it's performing as expected by moving over here to the right-hand side of the data view. Of course, it was always good practice to comment what we're doing, and in this case, what I'm going to do is rename this operator to more accurately describe what I've done here, which is generate renewal status. We can now create the next step in our data pipeline, and what I'm going to do here is do some binning of numerical variables. First off, I'm going to use discretize by binning, and I'm going to connect the data on the input. I'm going to select the single attribute, and first off I'm going to bin income. So we're going to update the metadata so I can access the income column. Then I'm going to say I'd like 5 bins, and I'd like them named based off the interval that they are creating. And again, good practice, we're going to name our operator discretize income. Then going to drag on another one. This time I'm going to define the bins that are created. So again, we're going to select single, and this time we're going to do attendance percentage. So I'm going to then select that column over on the right hand side, and then we choose the classes. So I'm going to create a low class for anyone whose average attendance was less than 80%, a medium class if it was between 80 and 95%, and then I'm going to create a high class if their attendance was above 95% for that previous season. And again, I'm going to comment my operator to make sure I can look back and see what actions were performed. Next, we're going to do some more calculations. So I'm going to go back and I'm going to go to generate columns. This time what we're going to do is a date calculation. We have present in our data set the date when the season ticket holder last moved in to their current address. What we'd like to do is extract the number of weeks between then and now, as this may influence whether or not they're likely to renew. So what we can see here is that we have a number of different types of functions, and specifically we have some date calculation functions that we're now going to utilize. So here I'm first going to go and type in date diff, or a date difference calculation. And we need to give it 4 arguments. So the first argument that we're going to give is our starting date, and we already have that in our data set. So I can type in moved into current residence. The next argument, we're going to use our date now function to fetch the current date. We're going to then say the units that we want to use, so it's date, unit, week. And then finally, we're just going to specify what time zone we'd like the result to be in. So it's, in this case, Europe, London. And we then close the parentheses and click save, and then close the function builder. And again, always good practice. We're just going to comment that we are generating a new date calculation. So the final step here is I'm going to remove some columns that I no longer need from my data set. And here we're going to use the select attributes, which you could also think of as select columns. We're going to select the type to be exclude attributes. We're going to select a subset, fetch the metadata that we need, and then what I'm going to do is remove 2 columns. So I'm going to remove the moved into column, and I'm also going to remove the renewal date column, as I no longer need them for my data. We then finally, we're going to use this output option, and we connect our data into there. We're going to turn on save results, and we're going to save this data back into our data catalog, and we're going to call it prepared data. Now we can move on to applying machine learning. There's a few different ways we can apply machine learning, and the first way I'm going to show is using automated data science. So I have my dataset open, and I'm going to click Open Auto AI and specifically use the Auto Machine Learning option. So I'll create a new analysis, and here what it's going to do is enforce good data science practices but hide away a lot of the complexity for me to allow me to quickly create a number of different machine learning models. First off, I'm going to choose the column I'd like to predict, which in this case is renewal status from the dataset that we've just prepared. So I will click this, and then can see the count of my different categories. If we click Next, we can now choose the columns we want to use to make the prediction. The software automatically gives us some feedback of what might make good and bad columns. We can also manually change it, such as removing the ID column here. We then choose our algorithms, and we have some presets available, or we can turn on the advanced settings for some more fine-grained control. In my case, what I'm going to use is the higher accuracy option, but also turn on some column analysis for some extra feedback on my data. Now click Run, this is submitted, and those different algorithms trained. What we're now going to do is skip ahead to see the results. Our AutoML process automatically extracts key metrics that we can use to compare model performance for the different types of algorithms. We also have access to a model simulator, which I'll come back to. We have the global weights, so we can see which variables are important. We can also look at individual models, looking at their individual performance statistics, look at their individual weights and variable importances, or the production models themselves, such as for this generalized linear model. We can use the model simulator to test new values, so I could try a new set of inputs such as age, maybe distance from the stadium, their attendance percentage, which I'm going to set to low here. Or perhaps we could also change the number of years that they've been registered, because we know that's an important column to predict. And if I lower this down to 1, we see that it's now predicting that this person wouldn't renew. We can use the workflow designer to create machine learning models with more fine-grained control. Here, first, I've created a machine learning model on all of the training data with nearly 89% accuracy. What we're now going to do is investigate if we can approach the most predictive variable, the number of years attended, to become more predictive. So here, if I make a model for each year, we get above 89% accuracy, and then we can go and investigate the performance on each individual year. So for year 1, we get above 93% accuracy, for years 4, above 93% accuracy, and year 5 above 99%. For years 2 and 3, we show lower accuracy, so maybe we need to approach these differently. Below, what I've done is shown modelling for year 1, modelling for year 2 and 3, and then years 4 and 5 to further boost the accuracy to above 89.4%. Back in Panopticon, we have the data for our proposed season ticket holders for 2025, and we're using our deployed machine learning model to predict whether or not they're likely to have renewed their season ticket. We're then counting the number of holders as well as estimating the revenue that we would receive. We can then change the proposed price increase to see what effect that would have. We could even run an optimization to optimize the price increase to maximize our revenue for 2025.